Selamat pagi. Good morning. Today, I would like to continue our class in physics. Today, we will discuss about the electric charge and fields. Okay. Maybe you remember the physics or the science class in elementary school. If we have two glass rods like this one, we have two glass, and then with a silk cloth, and one was suspended by thread. When they are close to each other, they repel each other. And then when the plastic rod was rubbed by fur, when brought close to the glass rod, and the rods attract each other. So if we have two glass, and then we call it the key or the charge of the glass is the similar. It means that maybe you remember that if the charge is similar, like negative to negative, positive and positive, and then they will repel each other. But if we have two material, they have a different kind of the charge, so they will attack each other. Okay, so the kind of charge will determine the glass or the material will attract each other or repel each other. So yes, like this one, it is the first one. The two charge rods have the same sign, so and this the positive sign or positive key or positive charge, so they will repel each other. But if two of the material like glass and plastic has a different charge, the glass is positive and the plastic is negative, though, so they will attract each other. So we call it electric force. So and then before we discuss about the electric force, so the first we have to know what is the electric charge. The strength of the particle's electrical interaction with the object around it depends on the electric charge. So electric charge is represented by the key, which can be either positive or negative. So the key can be key positive or the key negative. And then the particle with the similar sign of the charge, it will be repel each other. But the particles with the opposite sign will be attract each other. And if we have the some object with equal amounts of the two kind of charge, so we call it neutral. So it's like we have some material, and then if we put with another material, another similar material, and then there is no electric force. They didn't attract each other or they didn't repel each other. So it means that the material is neutral. And if in this material, if there is an imbalance electric charge, so it has an excess charge. So the excess charge will be negative or positive. It will be determined what is the charge of the material. So it's like this one. We have the charge object. This is the positive, and then we have the insulator. The insulator is the neutral material. So if we put the charged object to the insulator close each other. So the negative charge of insulator will be attracted to the charged object, the positives like this one. So the charge in the insulator will be moved or will be uh, changed depends on what is the charged object around the insulator. It's like this one. We have the material like this ones, and we like put our head, and then we will make this material become negative or positive. So if we put it to like a small pieces of the paper, so we can attract a paper. It means that the the charge of this material, this kind of material, and the charge of this kind of material is different. So the both of material will attract each other. And we have three kind of the material. The first one is conductor, and the second is semiconductor, and then insulator. Conductor are material in which a significant number of the electrons are free to move. And then the charged particle in non-conductor or insulator are not free to move. It's like this one. So it is in insulator, and we have the conductor or metal, and then in insulator the electrons or the charge not free to move. It means that the valence electrons are tightly bound. It's like we have the nucleus, core electrons, and valence electrons. They will be tightly bound. But for the metal, they didn't. Yeah, so the electron can be free to move because the the bonding in the metal of the charge in the metal is not very tight, so we can move the electron or the charge in the metal freely move to another positions or to another material. And then if we know the so the if the electron move from one side to another side, we get the currents or the I. I is the rate of the key per dt. It means that the charge past the point, so the I or the current it will be the key per dt. So how many charge per time unit? We call it the current. And then the columns describe the electrostatic force or electric force between two charges of particle. So if we have the particle charge Q1 and Q2 are separated by distance of r, so they will be attract each other or repel each other depends on the kind of the charge and how much the force between two charges. So we using this formula, F is 1 over 4 V epsilon 0 multiplied by Q1 Q2 per R square, where epsilon 0 is this one, it is the permittivity constant, and then the ratio of 1 over 4 V epsilon 0 is often replaced by the electrostatic constant or Coulomb constant by K is this one. So by using this formula, we can easily determine or define what is how much the force between two charges. We know that the material 1 have the key something, and then the material 2 have the key or the charge something, and then the distance between the material is is something. So we can define the force. So yeah, we have discussed this before. It's like this one. If we have two similar kind of the charge, this one. So the first one, how to determine the force is we have to draw the force vector. So this is the positive and this is the positive. So they will be repel each other. So the we have to throw the force in the, we said it is first material, and then this is the second material. So both of the material will be repel each other. So this is the force because of particle 1, and this is the force because of particle 2. And then the force pushes the particle apart. So it's similar. This is negative, or this is negative. So this one, this is the force because of this, because of we call it like a 4 and it's 3. So this is the force because of the particle 4, and this is the force because of particle 3. And if the charge is different sign, like this one, the positive and negative, so both of the charge will be attracted each other. So we have to draw the force like this ones. We call like this particle 5, and this is particle 6. So this force is the force because of particle 6, and this is the force because of particle 5. Oh, okay. So the electrostatic force acting on the charged particle due to a second charged particle is either directly toward to the second particle opposite sign or directly away from it. If we have the similar particle, so it will be repel each other. So if we have the different particle charge, so they will be attract each other. And then it's with other type of force. If multiple electrostatic force act on particles, so the net force is the vector sum. So the vector sums of the individual force, not a scalar sum. We will discuss later. It's like this ones. So we have the similar sign of the charge. This is the key 1, and this is the key 2. So the first how to solve these questions or these problems is we have to draw. The first one, draw in Q1. So this is the F12. It means that the force in material 1 because of the material 2. And then we have to draw, because this is the similar sign, so they will be repel each other. So the force of the electric force in particle 2 will be like this one. So this is the F21. It means that the force in material 2 because of material 1. Okay, don't forget to remember the notation of the force, because if we have the problem, so it will be easy to solve if by using the similar kind of it, like this one, F1 to F21, or like something like this one. So the distance between the Q1 and Q2 is this one. So we have the factor R1, and this is the factor R2. So the distance is R2 minus R1. This is in the factor. So we have this one, so we can solve this problem. So the F12 is K multiplied by K1, K2 per R12 square. So it's similar to K, K1, K2 per R12. Yeah, so this is R12 hat. So we can use this one in factor. So in R12 hat is R2 minus R1 per R2 minus R1. We have talked in factor how to solve or how to measure the distance in factor. And then K is the column constant, and K is 9 multiplied by 10 over 9 Newton meter square per column square. And epsilon 0 is this ones. So this is the questions, the easy questions. A and B is repel each other, where key A is equal to key for key B. Which statement is correct? The first one, FAB is larger than FBA. FAB is smaller than FBA or similar. So we have to draw. The first one is this one. So this is FBA, force in material B because of material A, and this one is FAB, force in particle A because of particle B. So we use the column formula. FAB is K A KB per R square. R square is the distance between RA and RB. And FBA also similar. K KB KA per R square. So yeah, this is a similar. So we have so we have to choose the 3. FAB is equal to FBA. Okay, and then this is the elementary charge. Electric charge is quantized, restricted to a certain value. So the charge of the particle can be written as Ne, where N is positive or negative integer, and E is the elementary charge, which magnitude is the charge of the electron and proton, 1.6 over 10 minus 19 coulomb. So it's like a 10 to 1000 E. It means that 1000 multiplied by this this elementary charge. So this is the total charge in the material. So this is the elementary charge. The particle is electron, proton, and neutron. So the symbol is E, P, and N. And this is the charge minus E plus E and 0. 0 is means neutral. The total charge in the material is similar. So this is neutral or neutron. And then this is the conservation of charge. The net electric charge of any isolated system is always conserved. So E minus plus A plus is mean that gamma plus gamma is I minus plus I E plus. So this is the total charge in the material. So this is the exercise 1. So I will talk fast. This is two similar particles of key fixed in a place on the key axis. Y is equal to 0, Z is equal to 0. X1 is plus 1 meter and X1 is minus 1 meter. The net electrostatic of the particle F3 net is equal to 0 due to the first and second particle if it is isolated in. So and then draw the net electrostatic of the particle. So this is the key of the similar particle or similar charge. And then the first is in a positive. This is the positive x, and this is negative x. Plus 1 and minus 1. So the electrostatic of the particle F3 net is equal to 0 due to the first and second particle if what is the location, so the net electrostatic of the particle will be 0. So you have to choose whether wherever the location of the quartile of this position, so the net electrostatic of the particle will be 0. The first one, we have to draw the net electrostatic of the particle, and then draw the net electrostatic of particle 3. Like I put in the center in the middle of this particle, like this one. So this is the particle 3. Like it's particle 3. So the particle 3 is equal charge. So it means that we have like this Q1 and Q2. So because of the particle 3 has the similar charge, so we have to draw in Q1. So this is the Q1, F Q1 3, yeah, Q3, yeah, Q3. Okay, and then in Q2 is F Q2 Q3. Okay, so if we use this assumption like this one, well, if the charge is similar or if the charge is not similar, like it's negative, so the electrostatic in particle 3 is almost or is similar to 0. This is if we put this is positive like this one. So the F Q1 Q3 is equal to K Q1 Q3 per 1 square, right? Because the distance between Q3 and Q1 is 1. And F Q2 Q3 is similar. Q2 Q3 per 1 square. So it's similar. And then because of similar, so the net electrostatic force or the the total force in particle 3, it must be 0. Okay. And then this is in particle Q1 and this is Q2. If we draw in Q3 like this one, so maybe I make this, we can draw in here. This is the F Q1 Q3 and this is F Q2 Q3. Okay, so this must be 0. But if we change it to the negative, if we put the charge Q3 here, this Q1 and Q2, Q3 is negative. So the force in Q3 because of particle 1 is must be like this one. It will attract each other also. F Q1 Q3 and here is F Q3 Q2. I make mistake here. So this is F Q3 Q1 because the first we have two states the location. So F Q3 Q1 is equal to F Q3 Q2 and the amount is similar. So the signs of the charge in Q3 is free. I mean that it's not deep. It will be okay. If the Q3 is negative, as long as the position of the Q3 in the middle of the Cartesian like this one, so the net force must be 0. And also, if the charge of Q3 is positive, as long as the position of the Q3 in the middle or in the center of the Cartesians, so the total electrostatic force it must be 0 also. So this is the answer of this problem. Okay, maybe this is for the electric charge. Thank you very much.